Hey Algebra 2 students! So like I mentioned in 4th hour today, we didn't have a chance to get to the graphing of complex numbers together. But this is a really easy topic, and so it's something I think we can just watch a quick video for, and you'll feel prepared to approach the 2 or 3 problems that involve this on tonight's homework. So when you are graphing complex numbers, it's very, very similar to the work that we do plotting points in the XY plane. What you just want to keep in mind is that when you plot imaginary numbers, you're working on what's called the complex number plane, which means that instead of an X and Y axis, what you have is a horizontal real axis, and then you have a vertical imaginary axis. So you can think that instead of plotting X and Y coordinates, you're plotting numbers that have a real component. So that would be your regular numbers like 2 or -5. And then you have an imaginary component. That's the value that has an I attached to it. So the first point I want us to plot together is this one, letter A, which is 4 minus 4i. So if we think of breaking that apart into a real number and an imaginary number, the real number is 4. So you want to go over 1, 2, 3, 4 units on your real axis. Then you have a minus 4i. So -4 is your imaginary term, which means you want to go down 1, 2, 3, 4 units on your imaginary axis. So this point down here is what we would label as A. So really just like plotting X and Y points. Same thing with part B. The horizontal component, the real number, is -2. So I just go 1, 2 to the left or in the negative direction. And then the imaginary component is just the 3i. So in order to account for that, I just go up 1, 2, 3 units, and I label that point there. So this would be the point B. The last one we have is C, 5i, and that one, if you check it out, it only has an I term, which means it just has an imaginary component, not a real component. So we're going to stay on the imaginary axis here and go up 1, 2, 3, 4, and then 5 would be right up here. So this point would be C. So those 3 different points are all that you need to plot on your imaginary and real axes in what we call the complex number plane. So all of your graphing on tonight's homework will look the same. The other thing that we want to do that is involved with graphs is to find what we call the absolute value of our complex numbers. So there's a specific absolute value formula when you're dealing with a setup where you have one real number and one imaginary number. So the formula that you want to be able to work with is that A plus BI is equal to the square root of A squared plus B squared. Now you guys, this is actually just a version of the Pythagorean theorem. So you're more or less finding a hypotenuse when you're finding an absolute value for a complex number. So if you want to try this with point A that we looked at up above, we had 4 minus 4i. So if you want to find the absolute value of that, we can put it in absolute value bars like this. Then what you're going to actually end up doing is just taking the square root of 4 squared plus -4 squared. So 4 is my A term. My B term is just the number that's in front of the imaginary number. So in this case, it's -4. And so what I want to do here is take 4 and square it. So that'll be 16. -4 squared is also 16. So this becomes the square root of 32. But then just like before, we want to simplify this to 16 times 2. The square root of 16 will simplify to 4. And so we'll have 4 times the square root of 2. So that's our final answer for the absolute value of that complex number. So that would be our final answer here. Let's do one more just so you have another one for reference. If we wanted to find the absolute value for point B, that's -2 plus 3i. So again, if we put that in absolute value bars here, -2 plus 3i, then we can go ahead and square root here, -2 squared, and then 3 squared. Again, the I doesn't come along with us. And when we get that result, we'll end up with 4 plus 9, which in this case is going to be the square root of 13. We can't simplify 13 anymore. We're kind of stuck there. So that's going to be our final result for that absolute value. So that's it for your graphing, you guys. You're plotting your points, real axis, imaginary axis, and then from there you also just want to be able to find your absolute value term. Let me know if you have any questions on this. Again, you really should just have one problem from each topic here for tonight's homework.